Okay. Yesterday we have seen various processes, including adiabatic process. Was there any homework? I think we have done all the question. Now we are going to see the second law of thermodynamics. Let's see. First law, first statement is there, Kelvin Planck's statement. So this is about the heat engine. Consider block diagram of heat engine. Suppose this is the, we are showing the block diagram of heat engine in which there is the hot source which will supply the heat, for example Q1, to the working substance. Here will be some working substance and W will be the work done and Q2 is the heat rejected. All right, so some input is there, some output, and some of the heat is rejected to the surrounding or cold reservoir. Okay. So second law, according to second law, Planck's Kelvin statement, it is about the heat engine. This, according to this law, there is no heat engine possible in which all the heat supplied is converted back to the work done and no heat is rejected. We cannot construct the engine in which all the energy, all the input energy is converted to the work. ऐसा engine नहीं बना सकते. It puts the restrictions on that. Why we cannot make? Because if we see the formula of heat engine, in that for converting all the heat energy to the work done, there should be infinite temperature of the source. Source should have infinite temperature, which is not possible, physically possible. Even if we have the zero friction, पहले तो friction में ही कुछ loss हो जाएगा. But if consider there is no friction, then also we cannot convert all the heat energy into work without rejecting any heat to the surrounding or to the cold reservoir, we call it, or surrounding, we call it. So that is what is the second, first statement of second law. No process is possible whose sole result is the absorption of heat from the reservoir. Hot source को reservoir बोलते हैं. And complete conversion of heat into work. Complete conversion is not possible. Some heat is to be rejected to the surrounding. Then only heat engine will work, because there is a condition of temperature limit. We cannot achieve the infinite temperature or 0 Kelvin of the cold reservoir. So temperature limits की वजह से all conversion of heat is not possible. That is what is the second law, first statement. ठीक है. Another is about the refrigerator. Second one is about the refrigerator. उसको हम समझने के लिए suppose थोड़ी देर के लिए हम consider करते हैं. एक there is the hot coffee in the room. ऐसे समझिए, यहाँ पर hot coffee या hot tea is there. Heat, it will supply the heat to the surrounding. है ना? Surrounding को heat दे दी, है ना? Is it possible कि heat surrounding which is at मतलब surrounding which is at lower temperature, है ना? ये इसका temperature T1 है, surrounding का T2 है, तो T1 से T2 तो heat चली जाएगी. But if heat comes back, the heat comes from, can the surrounding give the heat to the hot coffee? इसमें heat आ सकती है? No. Even if first law is valid, first law क्या बोलता है? Heat conservation, है ना? Whether heat goes from the what is called hot to cold body or cold to hot body, heat will remain conserved. But first law is, there is a limit for first law. It doesn't say heat will be spontaneously coming back from the cold to hot reservoir. Heat बाहर से अंदर नहीं आ सकती. Hot से cold में तो जा सकती है, but cold से hot में नहीं आ सकती heat without any external support. That's what is the second statement. Second statement क्या बोलता है? Cold से heat हमें hot source में transfer करनी है, so it is not spontaneously possible. On its own, it is not possible. We have to have एक्सटर्नल सोर्स, जैसे रेफ्रिजरेटर है, रेफ्रिजरेटर में there is a refrigerator, let's see, ठीक है, तो दिस इज कोल्ड, कोल्ड से हीट बाहर निकालनी है हॉट सराउंडिंग में, इट इज नॉट ऑटोमेटिकली, इट इज नॉट taking place even if first law is not violated. First law says, okay, energy conservation should be there, total energy should be conserved, but cold से hot में जाएगी कि अपने आप नहीं जाएगी, it is not spontaneously on its own, it cannot go. We have to do some work, कुछ वर्क करना पड़ेगा, कुछ सोर्स चाहिए हमें, this is to be done. तो compressor is there, compressor is doing this job, which are helping heat to take out from cold to hot. Reverse flow जो है ना, on its own it will not be there, we have to have some external source. That's what is the Clausius statement. No process is possible whose sole result is transfer of heat from colder object to the hotter object. ठीक है, yes. तो इसमें we should have the compressor. Compressor does this job on sole, on its own, है ना. No process is possible whose sole result is the transfer of heat from cold to hotter objects. ठीक है, तो क्या करना पड़ता है, कुछ वर्क करना पड़ता है, कौन करता है, compressor. Compressor takes the energy from the electrical source and does this reverse flow. अपने आप नहीं जाएगी ये, we have to do. So that's what is the clauses. These two statements you have to remember. First one was about the heat engine, second one was about the what is called refrigerator. ठीक है, all right. तो ये आपको याद रखना पड़ेगा. Heat engines and refrigerators, they are not in our, they are removed from the current course. अभी इस बार syllabus में नहीं है, so we can see later on while revision. First, we are going according to the course for this session. ठीक है, clear? क्या था first one? All the heat cannot be in heat engines. All the heat cannot be converted into the work. Some heat is to be rejected to the surrounding. And second one, heat cannot transfer on its own from cold to hot body. Some external source is required. As in case of refrigerator, we have the compressor to do this job. Cold से अगर हमें heat को बाहर निकालना है cold object से hot observer की तरफ reverse flow कराना है, it cannot be done on its own. We have to have some external source. ऐसा कोई process नहीं होगा कि अपने आप heat cold से hot body में जाए. All right, so this two statement you have to remember because they are the part of the course. And finally, reversible and irreversible process. इसके लिए suppose हम, if we take the two examples, reversible, suppose this is a piece of the paper, उसको आप fold कर दीजिए, and again you can unfold it. We can reverse the things. उसको fold कर दिया, फिर unfold कर दिया, so it is reversible. Whereas if you burn the paper को आप flame के ऊपर रख दीजिए, it will just convert it into ash. वापस उसको वापस ला सकते हैं paper? No, it is not possible. So folding and unfolding of the paper is reversible, whereas burning the paper in the flame is irreversible, which cannot be reversed. Paper, that ashes cannot be converted into back to the paper. So this is irreversible. Similarly, in thermodynamics also, if any process goes from A to B, A से B में, A to B we go, and then again come back to, then process is repeated back. It is, system is brought back to the initial state. हमने A से B में गए, and it can, any process is reversed back to its initial state without making any change in the universe, and also it remains in thermal and mechanical equilibrium. A से B तक जा रहे हैं और B से वापस आ रहे हैं. There is no change in the universe anywhere, and also throughout it should remain in thermal and mechanical equilibrium. The forces should be balanced, temperature should be equal. That process is called reversible process. अगर हमने वापस लिया, let us see thermodynamic process. State I to state F is reversible if process can be returned back to such that both the system and surroundings return to their original state. Original state में वापस आ जाए with no other change anywhere else in the universe. अगर वापस आ सकते हैं, that process is called reversible process. It is possible under two conditions. If we can maintain the two conditions, then only we can call it reversible process. Okay. First one is it should be quasi-static process. Quasi means almost static. Almost static में क्या होगा? Forces balance हो जाएंगे, मैकेनिकल इक्विलिब्रियम रहेगा, एंड टेम्परेचर भी इक्वेट हो जाएंगे, टेम्परेचर भी इक्वल हो जाएंगे. What I told. So this can be possible, but no friction or dissipating forces. Friction भी नहीं होना चाहिए. Otherwise क्या होगा? Some heat will go to the universe. It cannot be brought back to the system. Dissipate हो जाएगी heat, उसको वापस लाना नहीं possible नहीं है. It converts into heat and it will increase the temperature of universe. So it should not have the friction also. Practically this is not possible, है ना? Theoretically we can write reversible process, but practically some friction forces are there always, and we cannot have the reversible process. But then also we define, because it will be the benchmark. किसी process को हमें define करना है, किसी engine को, तो we take the reversible process, उसकी efficiency वगैरह में define करनी पड़ती है, तो maximum efficiency होती है. In reversible process, efficiency of heat engine is maximum, even if it is theoretically possible. Practically we will have some, but these are the ideal situations through which we define any what is called efficiencies. We relate the efficiencies with the ideal one. किसी engine की efficiency define करना है, तो बोलेंगे ideal as compared to ideal, it is this much or that much. So theoretically these things are possible, and which are benchmark for defining the other things. ठीक है, so you can just write short note on the reversible and irreversible process. Otherwise, if these conditions are not met, it will be irreversible process. Moment system has some friction, it will be reversible. If system is very fast, then also it will be irreversible. अगर हमने suppose piston को हमने fast expand कर दिया, है ना, outward, तो there will be more force inside, less force outside. तभी तो हम fast कर सकते हो उसको. तो forces it will not be in equilibrium, है ना. Mechanical, there should be mechanical and thermal equilibrium. Shall I write here? There should be mechanical and thermal equilibrium of system in reversible process. ठीक है, तो उसके लिए स्लो जाना पड़ेगा. very slow process, which is called quasi static, almost slow. तो forces भी balance होंगे, temperature भी, it will be uniform throughout. All right, if these conditions irreversible के लिए ये, you can just write your own. Irreversible will be one in which the process is very fast and there is dissipating forces, है ना. So when we reverse, we come back, the system will not be coming back to its original state. क्या लिखा है यहाँ पर? Turned back such that both the system and surroundings return to their original state. वापस जब आ गए, तो system का temperature, surrounding का temperature, जो था वॉल्यूम था, प्रेशर था, टेम्परेचर था, इंटरनल एनर्जी थी, जो पहले थी उतनी हो जाए। तो कब पॉसिबल होगा? जब देयर इज नो फ्रिक्शन एट ऑल एंड प्रोसेस इज वेरी स्लो। Clear? Anything you want to add in the reversible and irreversible process? तो कुछ ऐड करना है? Generally processes are irreversible. Thermodynamic processes are practically they are not, we cannot have the reversible process because some friction will be lost due to friction, some energy. System cannot be brought back to its original state. ठीक है? अब जैसे एक और एग्जांपल टेक्स्ट बुक में, सपोज यू ड्रॉप एनी ऑब्जेक्ट, सपोज आपने फिजिक्स की बुक ऊपर से गिराई नीचे, ठीक है, यहाँ पर आई, उसने हिट किया ग्राउंड में, some heat is produced, some sound is produced. Suppose you give the heat, again will it go back to the initial position? No, केवल हीट देने से और साउंड प्रोड्यूस करने से अपनी वापस इनिशियल पोजीशन पे नहीं जा सकती। तो सच प्रोसेस इज इरिवर्सिबल प्रोसेस, है ना? Object coming back, hitting the ground, producing the sound and heat. If we give the heat and sound, will it go back to initial state? No, it is irreversible. It is not possible. So like this examples are given in textbook, you can just go through. But condition for reversibility in case as far as thermodynamic process is concerned, we should have these two conditions. All right. Are you there or not?
Yes, sir.
Okay, तो short note you can expect. ये स्टेटमेंट आपको लर्न करने पड़ेंगे सेकेंड लॉ के दोनों, और ये entropy and enthalpy. It is, second law is related to entropy also, but it is in chemistry. Physics में there is no mention of entropy and all, so we are not just mentioning that. Second law we are not relating with the entropy. This much is there, so we'll confine to this much only. All right. So heat engine and refrigerator, they are not in course. We can discuss separately. So now moving on to the next one. Let's see. Just a minute.